Hello guys, this is understanding of the two-dimensional motion. You have already studied one-dimensional motion either with an acceleration or without an acceleration, and a vertical one-dimensional motion under the action of the gravity. Now, this motion, when a golf ball is hit with the golf club, ball moves in a path which you can see with the dotted lines. This path has a special property that the position of the object changes in both directions at the same time. For example, the ball was here at the start, and then after some time it reaches at this position. So we can see that it changes its position x meter in horizontal direction and y meter in the vertical direction. It means the position of the ball changes in two directions at the same time. So this kind of motion in which the object changes its position in both the directions, this is called as the two-dimensional motion. So we will study the two-dimensional motion of certain objects. You can see some examples. Then when a water from a pipe emerges out at an angle with the horizontal, it actually doesn't continue its path in the straight line, but it changes its direction. The mountains you can see, and the dolphins, they make a path which is not a straight line. When a basketball was actually sent to a basket, so it also makes a path that changes its position in two directions at the same time. And you can see a ski diver, so it changes its direction of motion and the change of position in two directions at the same time. Another example, when a cannonball is fired horizontally, the dotted line shows its path, its original direction of motion. Right from the beginning, it starts changing its direction of motion because of a force. You know, the force can change the direction of the motion. So here is the force which is responsible, is the gravitation force. You can see in these two examples, in this first case, the banana which is fired towards the monkey, it continued its direction of motion, but in the second example, a banana was fired in the same direction, but it changes its direction of motion. The difference in the two examples is actually the one is gravity free environment and the other is where the gravity is present. So actually the change of direction is due to the gravity or the gravitational force that changes the direction of motion of the. Let's analyze the direction, the motion in two dimension. The force responsible is the gravitational force, and you know the direction of motion and the direction of gravitational force is vertically downward. According to the Newton's second law, acceleration is directly proportional to the force, the net force, and it's always in the same direction as the net force. So if the net force here is the gravitational force which acts vertically downward, the acceleration is also vertically downward, and its magnitude is equal to g. This object starts with an initial velocity u at some angle with the horizontal. Initially, there are two components of the velocity. One is the horizontal component and the other is the vertical component. Horizontal component is responsible for the horizontal motion of the object, and vertical component of the velocity is responsible to raise the ball to a higher position. After some time t, it reaches to another location, so its velocity has been changed. Because the vertical component of the velocity changes, the direction of motion is opposite to the net force. Therefore, the vertical component of the velocity decreases to a value Vy. Vx is still the same as Ux because there is no force in the horizontal direction. Therefore, the horizontal component of the velocity is unchanged. The ball moves further, and the vertical component of the velocity decreases more, and ultimately it becomes zero. So at this position, the vertical component of the ball is zero. But we cannot say that the velocity of the ball is zero. There is still one component present, which is Vx, and this will tend to move the ball in the horizontal direction, but due to the presence of the gravity, this ball will not be able to go in the straight line, but will move in a path that is shown. The vertical component of the velocity appears again because of the gravitational force which is acting in the vertical direction, and now the gravitation force and the direction of motion both are in the same direction. Therefore, the y component now increases, and y, when it hits with the ground, it would have the same value as it was at the time of hitting the ball. So you can understand how the velocity changes, and where the acceleration acts, where there is no acceleration. So we can summarize this over here. When you launch up something at some angle, then the horizontal velocity remains constant throughout the motion. Vertical velocity is maximum at the start, zero at the top, and maximum at the time of landing. The horizontal acceleration is zero throughout the motion because there is no force acting in the horizontal direction, and we assume that there is no air friction. Vertical acceleration is equal to g throughout the motion. Even at the highest point, the vertical velocity is zero, but acceleration is not zero. And when something is launched at some angle with the horizontal, the horizontal velocity remains constant, and for example, this was launched with velocity u. It means that is equal to the ux, and uy is equal to 0. Vertical velocity is the start 0 and maximum at the time of landing. Horizontal acceleration is 0 throughout the motion, and the vertical acceleration is still the same at all the position because the force acting on it is the constant. you can see when at the start it was launched with the velocity of 20 meter per second. So it remains 20 throughout the motion, but the vertical component of the velocity increases. The negative sign here is actually to show the negative direction. So if we take upward as positive, then the downward is taken as negative, but it's a matter of choice of the directions, which direction you take positive. You can take, if g is positive, you take in this example, so then the vertical component of the velocity you can also take constant. That's not a problem. A two-dimensional motion is said to be a projectile when it's unpowered, it's unguided, and it only moves under the action of the gravity. Unpowered means there is no fuel, no engine, no motor, nothing is used for the object, and it cannot change its motion. Unguided means there is no guiding system and the object cannot change its direction of motion by itself. The only force responsible here is the force of the gravity. This kind of thing is called a projectile, and of course when we launch something vertically upward, this is under the action of the gravity. That's a one-dimensional projectile which we have discussed already. This is a two-dimensional projectile. This is also a two-dimensional projectile. So we will focus on a two-dimensional motion, which is a projectile motion. So how to deal with this kind of motion? Because we have the motion in two directions, so we are writing our equations of kinematics in two directions at the same time. So you can see I have written all the equations of motion which we have used in one dimension motion in two directions separately. We know that in the horizontal direction the acceleration is 0. If the acceleration is 0, then we can have these kind of equations, and this equation and this equation is actually none of the use. The only usable equation is this one. It means in the horizontal direction we can only use this equation, and in the vertical direction the acceleration is g, and you can write the equations in this way. We will take g as negative when the object moves upward, and when the g is taken as positive when the object moves downward. So we have now four equations to deal with the two-dimensional motion, but the question is, can we use these equations for the two-dimensional projectile? And the answer is yes. If the two motions are independent of each other. So the thing is, can we explain that this is independent motion? For example, the motion in horizontal direction doesn't affect the motion in vertical direction. To understand this, we do this experiment. A ball has been dropped from a certain height. It takes some time, let's call it time t1. And now the other ball is thrown horizontally with certain velocity in the horizontal direction. So it takes time t2. But the vertical distance traveled by the two balls is exactly the same. If they take the same time to reach, it means the horizontal motion of the second ball did not affect the vertical motion. And as a matter of fact, T1 and T2 are same. If T1 and T2 are same, this actually shows the independence of horizontal motion from the vertical motion. It means we can use these equations. So let's apply the concepts over here to understand the application of the equations of motion. In this example, you are asked to find this vertical distance y when a spit is done by a fish at an angle of 70 degree with a velocity of 3.5 meter per second. So there is 70 degree. We can make two components of the velocity, ux and uy. Ux is 3.5 cosine 70 degree. Uy is 3.5 sine of 70 degree. Now you are asked to find the vertical distance y. So vertical distance y could be found by using this equation. Sy is equal to uyt minus 1 by 2 gt square. The sign negative comes because the object moves in upward direction, but the acceleration is in downward direction, so g can be negative. Now the sy we can only find if we have the value of the t, because we know already what is uy. So how to find time of travel? To find the time of travel, we can use this horizontal distance, and you know the horizontal distance is given by ux into t. So we can find t if we know the horizontal distance and we know the horizontal speed. So that both the quantities we know in this question. So this is 0.4 which is given to you, and ux is 3.5 cosine 70 degree. So finding the value of t and then using the value of t over here, which gives you the vertical velocity. This is another problem in which actually you are provided the horizontal motion and the horizontal distance and the vertical distance, and you are asked actually to find what is the velocity when it hits over here. We can represent v here, and of course this has two components, vx and vy. So we can find v by using vectors, components of the velocity. It means what is required is vx and vy. To find vx, we use Sx is equal to ux into t. So it means you can find ux, which is equal to vx, because in the horizontal direction there is no change of velocity. We need time, and to find time we can use to find t using the vertical motion. Ui is 0 at the start. It makes our work more easier. So you can see we can find t by using this one, because ui is 0. So this is 2 into 67 divided by 9.81. This time you can use over here to find ux, which is equal to vx. Now to find vy. you can use this equation. Vy is equal to uy plus gt, 0 plus 9.81, and the t, the same t you can use over here. Now you have Vx and Vy, so use these Vx and Vy in this equation. So you will find the value of velocity when it hits with the ground or the other ship. This is another example because the aeroplane which drops an object is already flying with an initial velocity of 550 km per hour. It means the box which has been dropped also has the same velocity. So u is equal to ux and uy is equal to 0. So due to its initial velocity, the packet will actually go by making a projectile motion, and this is provided that Sy is 250 meters. So you have been asked to find actually whether it drops in the drop zone or not. It means you are asked to find what is Sx, and Sx you can find with this equation, ux into t. There is no other equation which you can use to find the horizontal distance. So for that you need the time. So this is the time to fall. So to find t, we can use Sy is equal to uy t plus 1 by 2 gt square, and then uy is 0, so this factor is 0. We can find t is equal to 2sy divided by g square root. That means by using the vertical distance we can find the t, and if you know the t you can actually find the horizontal distance. This you need to change in meter per second to find the distance in meter, because here you get the time in seconds. We are using g as meter per second square, so you need to change the 550 km per hour into. Hope that you can apply the equations of motion now in the two-dimensional motion. Thank you. Bye bye.